Hello, in this video, I want to show you how to test the mediation in multi-level models by using Sobel's test. Okay. In the past, it's convenient because we had a function called Sobel.lme in the R package Sobel.lme. So it did the Sobel test in the context of linear mixed models. However, now I just found out this package Sobel.me is archived and removed from CRAN. So the function Sobel.me is no longer available. I tried a couple different ways, and it's not in GitHub either. In this video, I just want to show you how we can manually implement Sobel's test for a longitudinal data set, okay, which is one kind of multi-level model. So let's load in the library LME4 for linear mixed models. And we set random seed, create a longitudinal data set, 200 subjects, 5 time points, ID time, a time invariant predictor X, and make the into a longitudinal format. And we create a random intercept for the mediator and random intercept for the outcome. That makes them into the long format. And then we assign true coefficient. A is 0.6 for the path from X to M. B is 0.7 for the path M to Y. And C0 is 0.2. This is the direct effect from X to Y. And we can create a time effect and for the mediator and time effect for the outcome. Okay, so we can create the simulate the mediation, which depends on a times x long from the predictor plus the time effect on mediator times time, and then you plus the mediator this the long format of the random intercept for mediator and plus a random error. And then also we simulate the outcome, which is the direct effects from x to y and plus b times the mediator plus the time effect of y times time and plus its random intercept plus a random error. And then we combine them into a data frame, and this is what it looks like. Okay, you get ID, you get time, you got predictor X, and you got the mediator M, which is time varying, and you got outcome Y. Okay, so now what we do is we're just very similar to we're doing the Sobel test for cross-sectional data. So first we fit mediator and outcome models. Now we call the function LMER. So it's M tier.x plus time plus parentheses 1 given ID, data equal to data. So this is a longitudinal linear mixed facts model for the mediator regressed on the predictor X plus time, and also it's taking into account of the within the same subject. So we do that. Similarly, we fit a linear mixed model for Y, which is Y tier to X plus M plus time, and also 1 given ID, the date. Okay. And after that, we need to extract the coefficient, which are the effects. So the path A from X to M, we can use fix EF, then model.m and bracket and double quotes X. This will give us the coefficient, and also we use the square root of a diagonal, the variance covariance matrix of the model.m for variable X, and that's the standard deviation. Okay, so similarly, we get the effect from M to Y. So this is the model.y and for M. Okay, and similarly extract the standard error no standard deviation. And then we calculate, we compute the Sobel test manually. We compute the indirect effect, which is A times B. And remember, this is only true when we have linear models. Okay, so you can, this indirect effect is the product of A and B. If you have other type of data, for example, like logistic regression, then you cannot direct use this. Okay, so you can also use the Sobel test formula for calculating the standard error. Then you get the standard error for the indirect effects. You can calculate the z value, and you can calculate the p value. And I want to unname the z value and p value. So what this does is to get rid of the name because it's going to carry the name x when we print out this value. So I don't want that. So remove names and put everything into a list. So you can see the indirect effect. I still carry the name x, but it's the indirect effect from x to m and to y. And the standard error, it says from the m. Okay, so it's the mediator. And what else here? And the z value, and the p value is very, very small here. It's like it's like 3.77 times 10 to the negative 10. So this indicates a highly significant mediation effect. Okay. So unfortunately, we have to do some legwork to implement the Sobel test in linear mixed effects model manually. And by the way, Sobel test is not very robust. As I say, it depends on the assumptions such as normality of the data. And the standard error estimation may not be accurate. So, and it must, it requires, you must have linear regression models. Okay, so to make the indirect effect to be A times B. Okay, and I will continue to search for other more advanced method for mediation analysis in the context of a multi-level model. And if you like this video, please subscribe to our learning channel, click on the notification bell, and like our video and share it with other learners. I would highly appreciate that. Okay. Oh, by the way, I will post these R codes in the comments area, and you can, just copy and paste and then play with it. And in the future, you may be able to modify it for your own research question, for your own data set. Thank you for watching, and I'll see you in the next video.